everyone, in this video we will see different forms of complex number. The first form, that is the usual form which we are writing regularly, is Cartesian form of a complex number, which is nothing but z is equals to x plus iy, where x and y are real numbers. Then there is another form which is called as a polar form. Now in the polar form of a complex number, we are going to take x is equals to r cos theta and y is equals to r sin theta. As we know that we can write in a polar form x as r cos theta and y as r sin theta. Therefore, the polar form of a complex number is z is equals to x plus iy, which is nothing but r cos theta plus I times r sin theta, that is equal to r into cos theta plus I sin theta. So this is called as a polar form. Now what is this r and theta? So it's very simple. R is nothing but the modulus of z, which is the square root of x square plus y square. And we know that theta is nothing but tan inverse of y by x. Now we will see what is Euler's identity. So cos theta plus I sin theta is equals to e raised to I theta is called as Euler's identity. As we know that cos theta plus I sin theta is e raised to I theta, we can also write cos theta minus I sin theta is equals to e raised to minus I theta. Now let us see what is an exponential form. So depending on the Euler's identity, we can convert the polar form of a complex number into the exponential form. We know that z is equals to x plus iy is a Cartesian form. Then we can write this in a polar form as r cos theta plus I sin theta. Because of Euler's identity, cos theta plus I sin theta is e raised to I theta. We can write down this as r e raised to I theta. So this is a Cartesian form, this is polar form, and clearly this is exponential form of complex number. So this is the way we can convert any complex number in the polar form and hence in the exponential form. Let us see a few examples of this. Let us try to find out the polar form and exponential form of these numbers. In order to find out a polar form and exponential form, we always require r and theta. So first of all, let us find out r and theta of all these numbers. R is nothing but modulus of z, which is nothing but square root of x square plus y square. That is nothing but the distance of the number from the origin. So all these numbers are at same distance from the origin, hence r for all these numbers will remain same. Let us try to find out r of 1 plus root 3i. So for z is equals to 1 plus root 3i, r is nothing but square root of x square plus y square, that is a square root of 1 square, which is 1, and square of root 3. So this is nothing but root of 1 plus 3, that is root of 4. So we will get the answer of r is 2. So here r is 2. Similarly, again for minus 1 plus root 3i, r will remain same because we are going to take the square of minus 1 and the square of root 3. So which will be the same, root of 1 plus 3, that will be root of 4, that is nothing but 2. Again for minus 1 minus root 3i, square of minus 1 is 1 and square of minus root 3 is nothing but 3. So again we will get r as 2. For 1 minus root 3i, r will remain same, that is 2, as square of 1 is 1 and square of minus root 3 will turn out to be 3, hence we will get root 4, that is nothing but 2. So in all cases r will remain same. Let us see what will happen with theta. Let us try to find out theta. So as we know that to find out theta, whatever is the value of z, I will always find out alpha. So alpha is nothing but tan inverse of mod y by x. So in the first case, tan inverse of mod y by x is nothing but tan inverse of modulus of root 3. That is nothing but tan inverse of root 3. Tan inverse of root 3 we will get for pi by 3. So alpha is clearly pi by 3. Here For all these numbers 1 plus root 3i, minus 1 plus root 3i, minus 1 minus root 3i and 1 minus root 3i, alpha will remain same because in all these cases alpha will be tan inverse of modulus of either plus minus root 3, which is nothing but tan inverse of root 3. So the answer will turn out to be pi by 3 in all cases. So for the first number 1 plus root 3i, number is in the first quadrant, so theta is same as alpha. So here the value of theta is pi by 3. For the second case, minus 1 plus root 3i, number belongs to second quadrant, and as the number is in the second quadrant, the angle will be pi minus alpha. That means pi minus pi by 3. So pi minus pi by 3, which will be 2 pi by 3. So here the angle is 2 pi by 3. For minus 1 minus root 3i, number is in third quadrant, so therefore theta is pi plus alpha. That means pi plus pi by 3. And in this case, we will get the answer as 4 pi by 3. For the last number 1 minus root 3i, number belongs to fourth quadrant, hence theta is equals to minus alpha. And here the angle theta will be minus pi by 3. So this is the way we can find out r and theta. Now we can easily write down the polar form of each and every number. So as we know that the polar form is nothing but r cos theta plus I sin theta. So using this here, the polar form of 1 plus root 3i is 2 times cos of pi by 3 plus I sin pi by 3. For minus 1 plus root 3i, again r is 2 and polar form will be cos 2 pi by 3 plus I sin 2 pi by 3 as theta is 2 pi by 3. For minus 1 minus root 3i, polar form is 2 into cos of 4 pi by 3 plus I sin 4 pi by 3 as theta is 4 pi by 3 and r is 2. For 1 minus root 3i, as r is 2 and theta is minus pi by 3, this we can write it as 2 times cos of minus pi by 3 plus I sin minus pi by 3, which we can also write as 2 times cos of pi by 3, because cos of minus theta is cos theta, but sin of minus theta is minus sin theta. Hence we will have here minus I times sin of pi by 3. So this is the way we can find out the polar form of all these numbers. Now exponential form is very easy to find out, which is nothing but r e raised to I theta. So here for the first number 1 plus root 3i, exponential form is 2 e raised to I pi by 3. For the second complex number, exponential form is 2 e raised to I 2 pi by 3. For third complex number, exponential form is 2 e raised to I 4 pi by 3. And obviously for the last number 1 minus root 3i, exponential form is 2 e raised to minus I pi by 3, because here theta is minus pi by 3, so it will be minus I pi by 3. So this is the way we can find out a polar form and exponential form of any complex number. Thank you.